Okay, so this is example 5.3.2. This is another projectiles question, and we're being told that a particle is projected from a point O with a speed of 25 meters per second at an angle theta to the horizontal, where tan theta is 4/3. Now, if we know that tan theta equals 4/3, we can use that information to try to find out what sine theta and cos theta are by considering trigonometry. So if tan theta equals 4/3, that means opposite over adjacent is 4/3. And then by Pythagoras, we can find the hypotenuse is 5. This gives us sine theta is 4/5 and cos theta is 3/5. We're going to need these in our calculation for later. For now, if we consider what the question's actually asking us to find, so find the equation of displacement. Again, if we think about equation of displacement, this is asking us to find an equation linking the horizontal displacement with the vertical displacement. So what we're being asked to find is an equation that links those two things together. So we're going to consider, as with any projectiles question, the horizontal motion and the vertical motion separately. So vertically we know that the displacement is y. The initial velocity is 25 times sine theta. And we know that sine theta is 4/5. So we know that the initial vertical velocity is 20 meters per second. Vertically, we also know that acceleration is -g. And we're going to say that this vertical displacement of y happens at some general time t. So we're going to let t equal t, and then we can form a suvat with this information. So we can write that y equals 20t minus g over 2 t squared. If we do a similar thing for horizontal motion, so the horizontal displacement at this general time t is x, the initial horizontal velocity is 25 cos theta, which is 25 times 3/5, which gives us 15 meters per second. And again, this happens at some general time t. So we can form with that x equals 15t. Now, if you think back to the chapter about parametric equations, we've got two equations in terms of t. We are going to try to combine these together. So we're going to rearrange one of them to make t the subject, substitute it into the other one. So we are going to write t equals x over 15, and then substitute it into y equals. So if we write y equals 20 lots of x over 15 minus g over 2 lots of x over 15 squared, which will then simplify down to y equals 4/3 x minus 49 over 2250 x squared, once we allow for g is 9.8. And then that's the first part of the question done. That's the part that talks about displacement. The second part of the question wants us to find, if I just go back to the question for a second, the second part of the question wants us to find the direction of motion when t is 3 seconds. So at 3 seconds, what direction is this particle traveling in? So in order to consider direction, the direction that it's traveling in, we first have to consider the velocity that this particle has horizontally and vertically when t is 3 seconds. So again, we create two separate suvat equations. So if I just write direction of motion here so that we know we're working on the second part of the question. Now for the direction of motion, we know that horizontally the velocity never changes because horizontally there is no acceleration or deceleration. So horizontally, final velocity, so velocity at 3 seconds, is still 15 meters per second. Vertically, however, it's not. So we have to consider what velocity is vertically when t is 3. So we know u is 20 from an earlier part of the question. We know a is minus 9.8. We know t is 3. We can use all of this to find v. So v equals u plus at. So it equals 20 minus 9.8 lots of 3. So v is minus 9.4 meters per second. So we know horizontally, we know the horizontal and vertical velocity at 3 seconds. To consider direction of motion, we put our horizontal velocity and our vertical velocity end to end. And then we consider the angle that makes with the horizontal, and that tells us what direction this particle is traveling in at 3 seconds. So again, if we have a look at this triangle that we've just created, it's a right angle triangle because x and y are perpendicular to each other. So we can write tan theta equals opposite over adjacent, which we can rearrange to give us inverse tan of 9.4 over 15 is theta, and that is 32 degrees to 2 sig fig. And then we can't just specify an angle, we also should specify where this angle is. So we would say 32 degrees below the positive x-axis. So that is the direction that this particle is traveling in at 3